Hello everyone, I recently ordered 4 of these Liitokala HG2 batteries and I decided to put them through a series of tests. These are 18650 cells, which are much more common than the 4135s I tested in my other video. They are a smaller factor and smaller capacity, but also a different chemistry. If you haven't noticed yet, the name HG2 is identical to an old LG model of 18650 lithium-ion cells, launched in 2015 and discontinued in 2018. So even if you find genuine ones, they are going to be at least 7 years old, which implies age degradation. These batteries are not original LG like in the other review where we looked at original rebranded EVE lithium iron phosphate cells, because these have 5-hole positive contacts, unlike the 4-hole original ones. Given that Liitokala is not a manufacturing brand and there is no official datasheet for these batteries, we can only use the specs from their cell page as a reference, where they advertise the cell can sustain a discharge current of 20 amps or 35 amps max, which is a bold claim even for LG. But the other measurements are standard. Capacity is 3000 mAh, internal resistance 15 milliamps, cycle life 1000 cycles, nominal voltage 3.7 volts, end of charge 4.2 volts, end of discharge 2.5 volts. Most of that corresponds with the LG datasheet except the end of discharge voltage, which is 2.0 volts in case of the original. Due to the fact that we can't be sure about the similarity of these two, and that discharging to 2 volts can shorten the lifespan of the cell significantly, in the tests, the batteries will be discharged to 2.5 volts. Before testing the cells, we have to check the voltages across each one, which are in order in this case, around 3.6 volts per cell. That corresponds to the storage voltage. We'll now charge one cell to 4.2 volts with the old laptop charger and a CC/CV buck converter. The cell is fully charged now as the charging current dropped below 50 milliamps. I left aside the battery for at least 10 minutes before beginning the discharging. The first test will be done at the current rate of 1 amp. There is no significant voltage sag, which is already good. The first test is finished and the battery gave a capacity of 2840 mAh, which is not too bad considering the 2.5 volt cutoff. As we can see, even on this website with original cell tests, the given capacity at 1 amp continuously is around 2.8 amp hours. In the second test, we'll check the 20 amp discharge claim from the seller's page and also maximum discharge current attributed to the original LG cells in the datasheet. This time, the voltage sag is noticeable as it fell down to 3.35 volts immediately. The cell was able to sustain a continuous current of 20 amps, but started heating up right away. From an ambient temperature of around 23 degrees Celsius, it heated up to 40 in 1 minute and 30 seconds. And at 2 minutes and 11 seconds it reached 50 degrees, at which I decided to stop the test in order not to overheat the cell. In these conditions it gave 726 mAh, but it is worth taking into consideration that the cell was not enclosed, so it had some air circulation cooling it. If it was used in a high current application like a power tool battery, at the same current rate it would heat up to the same temperature much quicker. And the third test will use the supposed LG datasheet nominal discharging current 0.2C 600 milliamps to test if the capacity will increase due to a lower current setting. As you can see, 4 hours and 44 minutes later, the test is over. The capacity remained the same within the measurement's margin of error. Thus, we can't expect more than 2850 mAh out of this particular cell. Lastly, there's the factual 1C 2.8 amp test in order to check how the cell performs in normal conditions, where it should give its capacity within an hour. For this one, I will be drawing a voltage curve to display the voltage changes along the duration of the test. Well folks, 2805 mAh of capacity in the span of 1 hour and 7 seconds. The cell kept a good temperature throughout the whole discharging process. As we can see, the voltage curve is good, with little initial voltage drop and a stable incline all the way down to 3 volts. This steep voltage sag below 3 volts proves that there is little capacity left in the cell, so even if we were to discharge it to 2 volts, it would bring little benefit at the cost of a substantially faster cell degradation. Overall, I'm satisfied with these cells. At little over $1 a piece on the deal that I got them, they bring good price to performance ratio. The capacity is close to the advertised one. They are capable of doing 1C charge and discharge cycles with no issues, even within enclosed spaces. As always, thank you for watching, and I will see you next time.